Assalamualaikum warahmatullahi wabarakatuh and good day. So we are from group 4 and we're going to present about a static equilibrium. So the topic that we had chosen and agreed together is a traffic light. So as you can see, this is our group members and work distributions. The first one is Muhammad Firdaus bin Wahab with ID number TH20041. He will do the first calculation part. The second is Muhammad Nafiz bin Muhammad Nasir with ID number TH20039. He will do the second calculation. The third one is Zul Khalid bin Mat Yassin with ID number TH20038 and he will do the calculation part 3. The fourth one is me, which is Nur Akila Kamaluddin with ID number TH20062. I'm going to do the application part and going to edit the video. And the last one is Nur Amiza binti Zainal with ID number TH20061. She will do the theory and steps part.
Theory of static equilibrium. Static is the same as equilibrium. Static is the study of force acting on an object that is either at rest or moving at constant speed in a straight path. We may say that an object at rest is in equilibrium or static equilibrium is described as Newton's first law. So the object in static equilibrium has zero net force acting upon it. There are two conditions when an equilibrium are met. The first one is when there is no net force acting on an object. That means F equals to 0. The second one is when there is no net torque in the system, when the torque equals to 0. In other words, the item is not going through anything. I mean, this acceleration along a straight line or rotational acceleration. The first condition of equilibrium, which is keseimbangan, as an object is in equilibrium, then the vector sum of all forces acting on the object must be 0. The forces acting on the object must passes through a common point. There are step-by-step on how to solve problem statics. The first one, you can make the drawing of the whole structure. The second one, you can choose the object and draw it separately. The object chosen must have many known forces and at least one of the unknown forces act. And then the third one, you can draw the free body diagram of the object, such as you can show the forces acting on the object, on the upward, downward, right, or left. The fourth one, you can superimpose an x-axis and y-axis on the force diagram. The fifth one, you can write an equation of the first condition equilibrium in x and y direction. And the last one, you can figure out on how to solve the equation, and you can rearrange the equation and solve the unknowns. So if the equation is not suitable for the equation, you can rearrange it until you can get the answer and until you can get the suitable equations.
So next, we move to the application of static equilibrium that really related into our daily life. So as you can see, the first picture is a traffic light. So this traffic light was hanging by two strings, which is to measure the force exerted at certain angle and to support their weight. So basically, this traffic light was found at abroad or other country, not in Malaysia. The second one is a frame of picture, which is just like the traffic light. The third one is a crane, which is a crane was holding a really heavy load and using a string too. The fourth one is a shirt, which is hanging by a hanger. Next, a swing, which is usually found at a playground. And the last one is plant pot that hanging by two strings too, and the pot contains soils and plant.
Alright, so for calculation 1, we chose the diagram about two flexible cables which is named as A and B that used to support a 300 Newton traffic light as shown in figure 1. So the tension in each of the cables is identified to satisfy the condition of equilibrium. Next, the condition is known net force is applied. So for submission of Fx is equal to 0, Ft2x is minus with Ft1x equal to 0, and then Ft2x is equal to Ft1x. So for FT2S, it is a cos 30, and FT1 is cos 35. And then FT2, we leave it as FT2 is equals to FT1 cos 35 over cos 30. And then we make it as equation 1, and we simplify the summation of Fy, which is Ft1y plus Ft2y minus with gravity Fg is equal to 0. Ft1 sine 35 plus Ft2 sine 30 is equals to Fg. And then substitute the Ft2 become Ft1 cos 35 sine 30 over cos 30. And substitute the Fg value given as 300 Newton, and we get Ft1 is equals to 286.67 Newton. And then substitute the Ft1 value into the Ft2, become Ft2 is equals to 286.67 cos 35 over cos 30, and we get the tension for Ft2 is equals to 271.15 Newton. Thank you.
Now let's continue to the next slide, which is the calculation 2. Given situation, a 35 kilogram traffic light hangs from a 8-meter long rod that has a mass of 40 kilogram and is supported by a cable at an angle of 30 degrees as shown in the figure 1. The question demands us to find the tension in the cable FT, which is the purple one that I highlighted. Okay, by using all this data, we can find the tension in the rod and the tension in the traffic light. To get this value, we multiply for the traffic light 35, we multiply with 9.8 and we get 343 Newton. For the tension in the long rod, we multiply 40 with 9.8 and we get 392 Newton. In this situation, no net torque is applied, so the summation of torque is equal to 0. From this situation, we can derive the equation TFT, which tension in the cable equal to tension in the long rod TCM plus tension in the traffic light. From this equation, we will get also the formula F we multiply with radius sin degree. So we substitute back in this formula derived. We will get Ft we multiply with x sin 30 equal to 392. We multiply with 4 sin 90 plus 342 multiply 8 multiply sin 90. And finally, we will get Ft multiplied with 4 equal to 1,398 plus 2,736. Finally, after we solve this equation, we will get the tension in the cable equal to 1,076 Newton. Thank you.
So for the third example of calculation for static equilibrium problem, a traffic light is supported by two cables as shown in figure 1. The tension in cable A is measured to be 294.8 Newton. What is the tension in cable B and what is the mass of the traffic light? So basically what we need to do is to assume that the net force is equal to 0. Since this is static equilibrium, therefore we know that the force in cable A is equal to the force in cable B. By substituting all the value given in the x component, we will obtain the tension for cable B, which is 278.84 Newton. Next, to calculate the mass of the traffic light, since this is static equilibrium, we can say that the total force for cable A and cable B is equal to the weight of the traffic light. We know that the formula of the weight is mass times gravity acceleration. After that, by substituting all the value given and 9.81 for gravity acceleration in the y component, we can obtain the mass of the traffic light, which is 31.45 kilogram.